to move. No worries. Welcome for those of you listening to the recording. I'm not going to go back through what I said before, but I'll just keep going. Right, so within GPUs, what I focus on is looking at how to move data around systems more efficiently. So one way that I like to think about that in a non-technical way is when we have systems that have, say, a CPU and a GPU, or maybe other kinds of processors like your smartphone does, the way they move data around right now would sort of be like when you're doing laundry. Say your laundry, your washer and your dryer are located next to each other and they're on a different floor of your apartment building or your house or wherever you live. The way we move data in these systems is sort of like if you took your laundry down or up to the laundry room, put it in the wash, and then when you came back, you took it out of the washer, you walked back to your apartment or back to your room, and then turned around and walked right back down and put it in the dryer. I would argue this is not a very eventful or profitable way to do your laundry. It's not very efficient, but this is how we move data around in these systems. So there's a lot of opportunities to be more intelligent about how we move data and make these systems more efficient, run faster with lower energy, and so on and so forth. And that's the kind of area that I work in particular, looking at the kind of next generation applications that run in these systems. So lots of things like machine learning, which Jerry will tell you all about in a minute, but also augmented and virtual reality, graph analytics, things like that. And so obviously, as somebody who works on hardware design, the kind of courses you could take if you're interested in learning more about this mostly end in the numbers 52. So 252, 352, 552, 752, as well as a couple others like 354, 757, and 758, are all the kind of courses that you could take where I might be teaching them. Broadly, as you might know from some of those courses, what we do is we take you from the very low level, learning how, say, binary works, all the way up to actually building, in hardware design languages, kind of a mini small processor of your own, and getting it to do some cool stuff. And so if you're passionate about building systems, or you ever wondered how your computer magically produced the things or the images, whatever you always see, these are really good courses to take. I remember when I was an undergrad, it wasn't until I took 352 that or 552, excuse me, that I really understood, like, oh, this is how my computer is producing the kind of things it's producing. Previous to that, I kind of just felt like there was this opaqueness there that didn't quite make sense to me. So if those are the kind of things that interest you, those courses would be really good options for you to take. And then outside work, just to tell you a little bit about myself when I'm not working, I'm really into triathlons and cycling. So you might see me out on the trails around Madison or the roads. And I also played volleyball competitively for about 20 years, so including when I was here doing my bachelor's and my master's. I actually checked before this meeting, and maybe one of you, but somebody recently finally updated the volleyball team's website to be not the one I created 10 years ago. So if you did that, good job. And if not, just an idea of, the kind of opportunities that I sought out and that I pursued while I was an undergrad like you. So I'm happy to answer more questions about any of that kind of stuff I mentioned, but in the meantime, I'll turn it over to Jerry to tell you a bit about machine learning and
All right,
himself, of course.
thank you, Matt. So I guess I'll just jump in and then we can answer all the questions. All right, I do have some visual. Let me see. Great, let's do that. All right, so people can see my screen, right? Yeah, okay, good. So yeah, about a little bit about myself. I have been here as a professor since 2005, so that's like 15 years. It's a long time, but it's fun. I started back in China. I was in Shanghai Jiao Tong University getting my bachelor's and master's. Then that was the time when China was actually opening up to the world. So when I graduated with my master's, IBM set up the very first research lab in China. So it's among the very first research entities there. So I decided, like, hey, let's see what research at IBM is like. So I joined IBM Research in Beijing for 2 years, and we were doing speech recognition for Mandarin. That was really fun. But that got me started really seriously thinking about machine learning. So after that, I applied to graduate school at Carnegie Mellon, got my PhD in Language Institute. So if you haven't heard of that, that's basically the place to go if you are interested in speech recognition, natural language processing. And in fact, that was before Carnegie Mellon had its machine learning department. So a lot of the machine learning stuff is happening. It's happening everywhere, but very importantly, happening at Language Technology Institute as well. So that's where I got my PhD. And then right now I'm still loving machine learning, of course. It's so fun and so many things to do. So my specific research though is a little bit sort of different than the mainstream machine learning. So in particular, I have started to think about this topic of teaching, where we all know like machine can learn. It's like a kid, you can make it learn, right? It's not often thought how we should interact with it, in the sense that if you have more information, can you act as a teacher? Can you help this machine learner learn better? And by that, we probably mean like you don't want to just feed it the kind of data set that people nowadays feed into machine learning. You want to have some more, kind of our targeted instruction, right? So all the things we do in real life as students, as instructors, as educators, we want a corresponding mechanism, but this has to be computational, and it has a very interesting theoretical aspect to that. You can, actually set up the theory of teaching in a computational way for your machine learners. So that's fascinating. And also, it has interesting applications. So one application is really coming back from the machine learning world, the teaching, theoretical teaching in there, to actually help education of human students. And this is essentially, treating human students as a computational device. Sorry, students, but you are nothing but a learning algorithm. So if you are a learning algorithm, we can actually work out backwards and say, if we as teachers know something about your algorithm, we should be able to optimize the curriculum that we use for you as an individual. Okay, so that's kind of the idea. And there is collaboration with psychology, with education, that we're really, pushing the theory to education. There's also another interesting application, completely different, which is to say that, hey, this notion of teaching a machine learning student could be misused, in fact, by bad guys. Who are the bad guys? Well, those are hackers. Hackers nowadays, they don't just hack your software. They can actually hack the data that your system sees. In particular, if your computer system has any machine learning component in it that can be influenced by bad data, then those hackers can, we call them adversaries. They can very carefully design the kind of bad input so that they're not easy for human inspectors to notice, but they will have a devastating effect on your computer system. So that's an interesting direction. And the reason we want to study that is to understand to what extent our computer systems that involve machine learning can be attacked. And conversely, how do we defend against that? So those are the type of research projects that my group has been working on. Okay, so, but that's enough of, university stuff, right? So the point of this meeting, part of it is to, show that, hey, Matt is a great triathlon and play volleyball. I didn't know that. And what do? So I do several things for fun, but really one great hobby I started during, actually during graduate school, or even before that, I guess during college, is astronomy. So I'm an amateur astronomer. And in fact, I have this web page that shows you that you as a student here in Madison, there is actually a decent chance, if you want, to see the Northern Light. And I have this web page that has advices where you can sign up for that. A bunch of photos I have collected over the years. These are all my photos, like the ones I saw. So I'm going to send a link to this group so that you have a chance to see that too. If you didn't know that, you can see that. So that's one thing I do. And let me stop sharing the screen. So another thing I do is I'm learning to paint. That is one of my paintings recently. It's my backyard. We have this sunflower, which one day this summer it was blown over by a strong wind. So all the flowers are dying. And I'm like, oh, before every flower disappears, let me quickly paint them. So there you go. All right, that's a little bit about me. So I will give back to Molly, and I guess we can open up for questions.
You're putting my daughter's
So you
finger
just
paintings
quickly-
to shame, Jerry.
No, kids always
I know,
have
you just-
the best painting. To be honest, I'm two of my kids, like whatever they do, their painting is so like unique and different. It's just good. And of course, we're parents, so we're like biased, anyways.
Highly biased, yeah.
Yes.
I'm not sure that I could just like whip up real quick this beautiful piece of art that you have behind you. So that is a beautiful painting, Jerry. So thank you for sharing these stories about yourselves. It's really nice to hear too that, you know, going into CS doesn't require you to just be stuck at your desk all day. Like you can do lots of other things and have other types of hobbies that are completely unrelated, and you know, or still relate them back, as in Matt's case, doing side projects of putting the website together. So that's really great to hear. I think what I'll do is just go through the list of the questions that were submitted in order, if that sounds okay. We haven't had any new questions come in the chat. So why don't we just go from there. So when you're applying to, because it sounds like both of you did do some industry work before going directly, you know, you didn't go directly into academia, which I think a lot of CS professors do. But how do you make yourself stand out amongst other applicants in these job applications to really kind of show who you are and that you're the one for the job?
Matt, you want to go first?
Yeah, I should clarify, you know, maybe my experience in industry was a little different than Jerry's because I didn't go and work, you know, full-time at at a company like IBM for an extended period like Jerry did. So, you know, take my advice with whatever, you know, grain of salt is appropriate there. But yeah, I mean, I think especially at big companies, whether it's IBM or AMD or, you know, nowadays Google and Facebook and the others, Baidu and so on, you know, there's going to be a lot of good applicants. You know, and I think like many of you or like all of you, they're all going to be pretty technically strong. So I do think, you know, having kind of some extraneous additional features, like, you know, maybe not being super combative with them and things like that, to show that you're gonna, you know, fit in addition to the technical skills you bring, can be important when, you know, they're making final decisions at the end of the day. But yeah, I mean, the most important thing I think in those cases is having, you know, the appropriate skills that they're looking for. You know, in my case, you know, somebody who builds hardware, you know, I remember when I was doing interviews as an undergrad, you know, they would ask me questions that seemed eerily similar to, you know, problems I'd get in, say, 354, 252, or other courses like that, right? That are testing kind of your basics, the basic knowledge and skills that you would know from taking courses like that. And, you know, I'll pause in a minute to let Jerry comment on the ML side of the world. But, you know, yeah, as in terms of systems jobs, I think that's the kind of stuff they're going to look for is, do you have, you know, the requisite skills to build the hardware, or design the operating system, or, you know, write the code, especially that's needed. And maybe that's, you know, one last thing I'll comment on that might seem underrated. Even as a hardware type person, I would say a significant portion of my time when I write code is actually spent writing like C++ or Java or CUDA, you know, or even higher level languages like than that. So being good as a programmer, even though it might seem silly if your goal is to design hardware, is actually very beneficial and can help you stand out in those kind of roles. So I'll let Jerry take it from there.
I completely agree. Let me add a couple things that I felt like would be useful. One is, you know, have high GPA is good. Okay, it's not the only thing, but it's very good to have high GPA. The other thing is some notion of you have been doing research, because once you're going back in graduate school, that's what it counts. So this could be in the form of, here are some projects I have worked on, and articulate why these are projects that's more than, just development, right? So if there's a research component, emphasize that in the statement. It would be great if you have had, some papers published, if not submitted, just to show that, you have been in, research a little bit. So these could be distinguishing features, but, nothing alone is super important. It is the whole you. So, just be yourself. But if you are applying, say, for a graduate school at some top universities, demonstrate that you have done research before or have considered that before, and demonstrate you have the ability to learn. That's very important. Your current skill set at the moment of application, it doesn't have to be a perfect fit of what the professors are looking for. And the professors understand that. But what they hope to see some evidence is you can learn things. That would be really useful.
Yeah, I think kind of the old adage that the best way to predict future success is past success is a good way to think about it, whether you're going into industry or whether grad school or whatever. Showing some evidence of succeeding, like you said, is a good way to think about it. One thing I forgot to mention before, which I'll just throw in because Jerry's comments jogged it. When I was an undergrad, another thing I did is I was on like the leadership committee for one of the student orgs that interfaced with companies and tried to get them to come in and give talks and work and recruit students and things like that. And I found that was also super helpful. It ended up making some very deep connections for me with companies like Qualcomm that I was able to leverage into interview opportunities and internship opportunities that would have been hard to get and hard to stand out for large, super successful companies like that. So, beyond the kind of more technical stuff we're talking about, that's another avenue you might consider.
Yeah, there's a lot of student organizations that do like field trips to companies and do alumni talks. A lot of students have probably heard of our SuccessWorks office, which is our career services office for letters and sciences. So they can also offer a lot of advice there too about like getting your resume ready, networking. They even do mock interviews and talks with alumni. So definitely check out and meet with a career advisor over there too if you have other questions about your applications. Thank you. The next couple of questions I think may be geared more towards Jerry because they're AI specific questions. Well, I know Matt did go over some of the architecture courses that are available at the university, but Jerry, what are the AI and machine learning courses that students might want to watch out for?
Right, so I'm typing in the chat so that we have a number there so students can refer to that. So there's the standard 540, that's the AI, intro to AI, but which really is turning into an intro to machine learning class. So that's a good one. 532 is offered mostly by ECE, but cross-listed with CS. It is called matrix methods or something like that, linear algebra, basically, methods in machine learning. It's a very good class. They are creating one more, which is like probabilistic models in machine learning. I forgot the number because it's new, but that would be the one you look out for. Then we have, so in terms of just like undergrad exclusive courses, there are some, it's related, right? We do not have an NLP course yet, just because we don't have somebody here. I am going to offer a reinforcement learning topics course the coming spring semester. That's going to be a one-off thing, but we're also anticipating a new CS faculty member, Josiah Hanna, who is going to join in the fall. And he's doing research in reinforcement learning / robotics. So the offerings will be, increasing, in the next few semesters. We plan to do that.
That's awesome. You did mention NLP just now, and we actually had 2 questions regarding that. What are some of the trends in research specifically with, I had to look it up, I'll admit, neuro-linguistic programming, and what are some other areas, like until we have this new professor come in, what are some resources that students could use to study this on their own?
Good question. So I do have a outdated but not irrelevant web page. So let me explain. So there are some things that's common in natural language processing. Like, for example, because you are dealing with natural language, it is, you have to know how to think of language. So that's one common thing that hasn't really changed too much. So I would say go to kind of, I have the class material. So let me send a link here. This was a class I taught for many years, but then I just don't have the manpower to keep teaching that. I have to teach other classes in machine learning. So also that was outdated in one important aspect, which is that was pre-deep learning. So everything was without deep net. So if you look at the techniques, the algorithms, the computational models, everything has changed. It's all deep learning based now. So what would be commonly used is still kind of, actually most of the things are still relevant. It's just that it's missing this elephant in the room. The latest methods are not there. So take that web page with a big grain of salt. Now, if you are interested in just picking this thing by yourself, there are really many good tutorial or just online courses that are available. You can definitely follow that, especially if you're interested in more hands-on stuff. You can definitely download the deep learning models and follow along. So there are resources like that. What you cannot do probably is to handle really large models yourself, because that requires a lot of resources. But just to get the concept, I think you can with fairly basic deep learning, and potentially you can even run it on your laptop, that kind of thing. You can still follow along and get some idea. So that's kind of unfortunate, because we really should have a dedicated natural language processing class, and we're really trying very hard to set it up.
Great. Did I get the acronym wrong then? It's natural language?
Natural language, yeah, no way. I mean, neuro-linguistic, that is something else. It's a thing.
Oh.
The thing you have there is a thing. Except that it's a sort of a small specialized topic within the much broader umbrella of natural language processing. So that is a big,
too far advanced. I was too advanced with mine.
Yes, that is quite advanced.
So I'm going to hop to a question about research. We get a lot of questions about research from undergraduates. Is it normal or possible for a normal undergraduate, like around a sophomore or junior, they clarify, to participate in research without previous experience in that field? There are some questions here too about other professors who might be able to join the project, but maybe you could speak directly about your research. And if you are taking undergrads, and if so, what you're looking for, or any advice for that.
Matt, do you want to start?
Sure. Yeah. So as I mentioned at the beginning, I am an example. Oh, I see somebody posted some questions too, but we can talk about that in a minute here. Right. So I am an example of a student in undergrad here who did research as an undergrad and went on to other things. So it's definitely possible. I am living proof of that. And and I started doing research as an undergrad when I was a junior. So, more directly to the questioner, asking if it's possible for juniors to do it, it is. Let me read just the rest of the question. I guess the first thing I want to say there is everybody has to start somewhere, and I don't know about Jerry's group, but it's normal for new grad students or undergrads who want to do research with me or in architecture to have not done research in architecture before, right? So I wouldn't have that be a huge blocker where you're worried about not having done it before, because you have to start with something. And at least the way that I structure my group, especially for undergrads, so I have two really smart undergrads, hopefully, who are not sitting here listening me talk about them, but who work with me. When they came and approached me, the way we structured it is we set them up with something very small. So, they didn't get completely overwhelmed by, the enormity of these problems that by definition of being research problems don't have a solution yet. But we'd give them a small piece of something, say, a more senior student was working on, where they could work with that student and help them towards their goal. And then as they get more experience and get more comfortable, we'd have them branch out and work on, something bigger and that they could make their own. So that's the way I structure it in terms of trying to onboard undergrads and give them some experience without making them feel like it's this huge morass that's really difficult to solve, because of course research problems are very difficult to solve. Let me just check if there was another part of this. In terms of how, just to give an example, when I was an undergrad, I took 552. And I just emailed the professor of the course after I'd taken it, and said, "Hey, I took this course with you. I really enjoyed it. I was wondering, and I actually wrote some ideas that I had for research in that email. They were horrible ideas, but I think he was still impressed nonetheless that I had tried to come up with my own ideas." But I remember his response. He was like, "Yep, sure, but let's try this other idea instead." So he had my best interests, in mind for me, even if I didn't know well enough at the time. But in general, the undergrads who've worked with me, it's worked very similar. They've taken a class with me and they've done well and expressed some interest in pursuing research in that direction.
Jerry, do you want to go over the question?
Yeah,
And then
sure.
we can get to that one in the chat for you, Matt.
Okay, so yeah, I'm showing like this is again my group or people in my group previously, but I want to show like yes, I do work with undergrads. So these were some of the undergrads that I have had the opportunity to work over the years. To more to the point, how do you get started, right? So definitely talk to professors. So here's a secret. How do you talk to a professor that you never know? And if you shoot them email, what if they don't reply to you, right? Go to their webpage, find their teaching schedule, find their office hour. Okay, go to their office hour. Okay, so that's the time they're committed. They're somewhere, right? So they publish a link now. So just do that. Even if you have never seen the professor before, you don't need an appointment. Just go there and introduce yourself and ask questions. So you want to, sell yourself, but mostly, you want to get a sense if the professor has some open research problems that undergrads can take. Now, this is very important. As Matt said, what's important is for people with no prior research experience, it is very important that the professor and you identify a bite-sized problem that's not too crazy, that should be doable within a couple months, hopefully. That would be the right starting point. So it really is something small, but gives a good starting point for for people to for you to start. Now, what is important in my experience, if you start this, right? So first of all, you may have to talk to a whole bunch of professors before you find a project that may be good for you. But once you get started, I think there are two issues. One is really keep bugging the professor or / the graduate student there. It's very important you take the initiative to make sure things don't fall in the crack, right? So sometimes it's just like professors get busy and you get busy. So throughout the semester, it started great, but then nobody's working on it, and then at the end we forgot what we're supposed to do, right? So that's one possibility. So make sure you you do that, and related to that is be realistic about the time you can commit. We fully appreciate how busy you are because you're here to study. You have so many classes you have to work hard in. So your free time is really limited. And you have to have a life, right? So the actual time you can devote to a project is not that much. So don't overcommit and be realistic about this. But once you commit, as professors, we really hope to see you, committed to that, and maybe every week have a short, status report and so on. Many times it sort of, as I was saying, the collaboration sort of fizzles just because both parties get busy and they couldn't follow up. I think that's the main thing. So just knock on professors' doors or virtually, and stick with it.
I've heard so many times from professors that nobody comes to their office hours. So go to the office hours.
Yeah.
They're there waiting for you.
Yeah.
So that's great advice.
One thing I just want to add there for the people who are really gung-ho about doing undergrad research, if the things Jerry and I mentioned go well, the CS department does actually have a bachelor's like honors thesis, like I hate to call it program, but option that you can pursue. So if you're someone who's really interested in research and you start doing it when you're younger and that's something you want to do, potentially as a way with an eye towards grad school, you can talk to Molly or Shelby or the others, and they can kind of point you down those paths. I think Molly and I actually just worked on this for one of the undergrads who's working with me like last month. So, that's another option if that's something you're very passionate about.
I will, it's called Honors in the Major, and I will post the link to the guide here in the chat. And if you just scroll down to the bottom of that or click on the little quick link, it'll take you down so you can see what those requirements are. And it does require 2 semesters of a thesis research project that you work with the same professor. So yeah, if you do have other questions, definitely get in touch with advisors and we can tell you more about that. So we had a couple of questions in the chat. I think we could maybe hop over there. I think you can hopefully both see them because they're a little extensive, but One is for you, Matt. It says, with Moore's law slowing down, where do you see the computer architecture field heading in the future? I've heard and seen some examples of accelerators and hardware specific to machine learning, for example.
Yeah, so this is the billion or maybe $1 trillion question. This is certainly the question that's been driving my research and basically everybody's research in the community. So for those of you who don't know, Moore's law was, although it's called a law, it was really more of an observation by Gordon Moore, who is now the emeritus fellow at Intel, but at the time was like CEO, high-powered guru, grand poobah type person at Intel. And he made this observation that transistors, which are essentially these little pieces of silicon that we use to build all the computers we're using even right now, they kept getting twice as small and twice as fast without increasing power consumption every 2 years. Well, at the time he really said every 1 year. Later it became every 2 years. And really that observation or that law has been what's driven the computing field, people like myself and really everything we're doing right now, to be frank, for the past 50 or so years. And actually, this is a very good question, such that I'm gonna, in the background here, try to pull up a graph, because I actually, for fun on my own, similar to what Jerry mentioned, one thing I have been doing is I've been plotting the number of hits on Google per year about the end of Moore's law since the 1960s. So obviously I wasn't around in the 1960s, but thanks to the powers of Google, you can look up by year how many articles there have been every year in terms of when Moore's law is going to end. So the without spoiling the punchline too much, what I find fascinating is the number of articles about the end of Moore's law actually follows Moore's law itself. So basically we've been, this is kind of like it became a self-fulfilling prophecy that it kept getting better and better. It's also now become a self-fulfilling prophecy that we talk about how it's going to end soon. So let me just pull that up if you give me 1 second. But in the meantime, while I'm pulling that up, what I wanted to mention in terms of where we go. So in my opinion, this is actually a really good time to be a systems designer, to be an architect, because for the past 50 years, because of Moore's law, or if you will, because of the tyranny of Moore's law, we could just wait for 2 years and your computer would get faster and require less power, and your battery would potentially last longer because of that, and everything would be great. As a programmer, you wouldn't need to write better software because your hardware just got twice as good every 2 years. And that happened for 50 years, but that's not going to happen very much longer. People think it's going to end in roughly the the next let's say 10 years. So there's a wide range of predictions about when exactly that'll be, but roughly speaking, people think 10 years is pretty much when it's going to be done. So here, let me just briefly share. Hopefully everyone can see the slide. But this is actually my graph that I've been keeping that plot the number of hits on this end of Moore's law. And I actually put in a few fun articles that make me smile when I look at this trend. So back in 2000, in the halcyon days, Intel, everything was great. They were predicting 10 gigahertz chips by 2011. And if you fast forward to 2011, when we were supposed to have these 10 gigahertz chips, the articles were then saying the death of Moore's law will cause an economic crisis. So we didn't quite get there, in terms of where we thought we'd be in 2000. And if you look, we're kind of going through the 5 stages of depression here, with the articles kind of increasingly becoming, more and more draconian in their titles. And by the way, these are real articles. You can go and look them up if you'd like to read them. But what I really want to point out is, as of last year, the article title is now sort of towards the acceptance phase, where it's titled "The End of Moore's Law and the Return to Cleverness." And that's what I wanted to focus on to answer Prashun's question. Because we don't have this tyranny of Moore's law to give us that free performance, and I use free of course in quotes, every 2 years, there is no bad options anymore. So accelerators and better programming languages and interactions much more deeply between operating systems and hardware and machine learning and applications like Jerry, knows a little bit about from machine learning. We're seeing people turn increasingly towards doing those kind of things. And in the longer term, there's, other kinds of technologies, maybe like, quantum computing, that might end up bearing some fruit. I have my own, personal opinions about that, but I've talked enough already, so maybe I'll stop there. But yeah, accelerators and more parallelism and figuring out how to be smart and do clever things in the hardware is cool again. And that's why I think this is a really cool time to be designing these systems, because waiting 2 years for everything to get better, it's done. We're not going to get that anymore.
We can't wait 2 years anymore. It's got to be better now.
You're right. Well, thankfully, because we have enough major companies that stagger their release cycles, you only have to wait a couple weeks. So,
so I think we've got one more question in the chat, and then because we've got about 15 minutes left or so, I may switch over to some more of the advice type of questions that we got. But Jerry, I think this question is for you. It's kind of a long one, but I'll just sum it up at the end. What are your opinions on the roles of linguists in NLP?
Yeah, so I'm sharing this Wikipedia page. I hope everybody can see that. Just read the first paragraph.
Every time I fire a linguist.
So this is actually a really famous quote. The long story short, Fred Jelinek was behind IBM's speech recognition engine. And this was when I believe he was at IBM. And he noticed that In other words, what he noticed is what we are still seeing these days. Um, Data-driven approach with really simple-minded model with no sophisticated um, human understanding of the problem turns out to be working much better. So why is so? Uh, Perhaps it's because we are, as humans, we're very bad at introspection. We just don't know why we work. So the kind of linguistic theory is, reasonable, but clearly in reality, they don't reflect or they don't guide the computation of anything that relates to natural language. In fact, it is your question is actually quite deep, and being from Carnegie Mellon in the Language Technology Institute, trust me, this very battle is waged every day there. You have a group of faculty members who is more in the linguist camp, and you have the more data science / machine learning type, who is like, hey, let's do simple models, which makes no sense whatsoever, but it works. So I guess what my observation is, it is very hard to marry these two fields. Okay, doesn't mean we shouldn't try, but so far it hasn't been working. And maybe there is something seriously wrong about the way we, study the theory of language from a human perspective. But we also very clearly know that even with the fanciest machine learning, deep learning model, we are not modeling natural language. That is for sure. Everybody acknowledges that. It's just that nobody knows how to do better. Okay. So I would say if you are really interested in this, marriage between computer science and linguistics, by all means do that. But be aware of the historical pitfalls and the difficulties. However, the fundamental reason why we want to marry the two, that's still there. Deep learning is it's not really understanding language. Even for, say, GPT-3, the hottest thing now, it has no idea what language is. So we should hope that in the future, we must find a way to marry these two fields, but that could be a decade out. So we don't know. Great question, though.
Yeah, that's
Maybe a
very
good time to
interesting.
do research on it, though, then.
There's a senior honors thesis project right there. There's a really good question in here because the area of ethics has been coming in a lot in some of the discussions in the department too. So we did receive this question submitted prior concerning concerns regarding ethical technology. How should universities ensure graduates leave with an ethical mindset? Should meeting such responsibility take the form of a class or other things? I'm going to throw a link in for the ACM Code of Ethics so students can review those if that's there. But especially in the fields that you're in, where does ethics come into play, and how or do you incorporate those into your classes?
Yeah,
And
this is a fantastic question that I don't know if I'm well enough equipped to answer, but I'll try nonetheless. Yeah, so I do think, as the questioner highlights, traditionally as engineers, as computer scientists, we maybe haven't been as mindful of ethics as we probably should have been, and some of the things that have come out lately are perhaps a offshoot of that. In terms of how to fix it, I don't think there's any one thing that's going to fix it. I will point out that we are now starting to offer a course. I think Professor Barford is teaching it, maybe even this semester. If not, okay, yeah, Jerry just posted on it. Next year, as of next year, there'll be an ethics course as part of the undergraduate curriculum, which oh, there you go. Molly and Jerry are answering the question in real time. But yeah, so there is an ethics course that's coming. Perhaps a more callous view, though, is that taking one course is not necessarily gonna make you ethical by just having taken that one course. So probably in the long run, I think what needs to happen is it needs to kind of be institutionalized across the curriculum. Just like, learning how to program or learning how to exploit parallelism or things like that have or will become institutionalized. I think, every class is going to have to eventually start teaching ethics in some way. Yeah, since time's short, maybe I'll stop there. I can talk more if people have specific questions, though.
Yeah, okay, just to add a couple of things. Certainly, it should be part of CS curriculum, and that's what we're doing. So people would have, a common framework to talk about that. I mean, by the way, a lot of these things are complex, and the world hasn't reached a consensus yet, right? But it's very important to have this in everybody's mindset. I want to add one thing which is very technical. So if you are a computer scientist and you are interested in ethical problems, there is actually a new book by Michael Kearns. If you don't know him, he's from UPenn. And if you, I just send a link in the chat. If you go there, you will see like front page, front and central, the new book on ethical algorithms. What it is a technical discussion of how computer science, computational thinking can play in the world of ethics. So it touches upon privacy, fairness, things, all those kind of things, but from a very interesting technical angle. So I highly recommend you take a look at that.
Yeah, I think it's always changing. People can do, the saying, with great power comes great responsibility, and programmers have great power. So we have to be careful with how it's being used. We can go a little over 5:30. I have the Zoom set up till 6, but I do want to be respectful of everyone's time as well. Some of the last questions I just thought we'd sort of focus on, like general advice. So, some students are wondering, like, how did you get into your research field? How did you decide to teach? Like, if someone is, thinking about teaching comp sci, how did you get into the position that you're in or want to teach?
Yeah, so in terms of research, I think I mentioned that before, but after I took 552, I emailed the instructor for that course and, did some research with him as an undergrad and a master's student, which led to the work I did as a grad student, which led to my postdoc work, which, led to here. So it all kind of, maybe not linearly in the way I'm making it sound, but if you look at it from a high enough level, it all kind of flowed from starting to do research as an undergrad. I will say, just to make it clear that it doesn't seem so easy, every step of the way there, I would, look at the different options. So before I went into my master's, I interviewed, for companies. When I went from my master's to PhD, I did the same. When I was going from PhD to here, I interviewed at companies as well, just to make sure that the path I was going down is what I really wanted to do. And I think one of the really nice things about our field is that you have those kind of options, right? You're not pigeonholed into only having, a very small select number of choices along the way. And then in terms of teaching, I think was the other question. So same sort of thing. I'm super passionate about teaching. I really like doing it. That's one of the reasons I became, a faculty member as opposed to going into industry, was getting to teach, talented people like all of y'all who are listening. In terms of how it started out as being a TA when I was in grad school, or, being a tutor when I was in high school and in undergrad. We used to have this old program, which has been replaced by a new one now that I forget the acronym of, but it was called TBD, or TBR, which is tutor by request. And I was a tutor in that as an undergrad here. But yeah, if you want to go into teaching, I think kind of the natural way to go about it is, to continue on along the path Jerry described before and, go to grad school and request with your advisor that you TA courses, specifically courses in the areas you're interested in.
Yep, that's entirely true. And in fact, so the tutoring idea is also excellent. Basically, what you want is the ability or the experience to explain things to people. Okay, that's the way you practice this, right? So this could be in the form of you being a TA, being a peer mentor. It could be in the form of, you just give some technical talks, maybe locally to a small group, but all these things prepare you in how to explain, how to structure your thoughts so that other people can understand what you're trying to say. And that's the preparation.
Great, thank you. I did just throw in the chat too, if anyone on the call is interested in being a tutor with the CS department, we have the CS Learning Center, and you can take a course 502 for 1 credit to become a tutor in that class, and that link has contact information if you're interested. So
there's a question for you in the chat.
Of course. I think, is Andy still on the call? Maybe Andy, do you mind chatting the answer to that? He says, yes, you do have to take the class. Thank you. How fortuitous that he was on our call today. So here's a great question that's saving for the end. What is something you wish you had done sooner when you started working in your field? Matt, do you want to go first?
Sure, I'll keep this one simple. And I kind of mentioned it before, but even though I'd done some of it, I wish I would have started learning how to program at an even earlier age. So to give people, an answer or an idea, I took like AP computer science when I was in high school, and BASIC, which was an old programming language I'm sure none of you have heard of, when I was in high school. But even so, I felt like learning even earlier, and especially learning scripting languages like Python or Perl is kind of dead now, but Perl at the time, or Python, things that you can actually take as undergrads now at Wisconsin in some of the courses that some of the people on this call even are teaching. Learning how to use those at a young age, as an undergrad or even before, would have helped me a lot. And instead, I kind of had to catch up on those things.
Oh, so actually, so let's see. I actually want to follow up on this in the sense of learn to program early. I also started, I guess, around high school, and that was a time when I was back in China, right? So what we had at that point, I don't know how many people know about it, but it's Apple II. If you don't know what that is, it's a thing where you use a tape recorder, plug into the phone jack of the computer to save your program. So you actually literally write it on the tape, cassette tape. That was like extremely fun, because if you are not careful, you hit record again and you erase your program. Right, so it's like hardware at its like very interesting. So I started like that, but it was really fascinating. That got me hooked. So I think what got me into CS is the passion. Like I really like it. But in terms of what I wish I have done earlier, that would be to learn more math. So I think for those of you who may not know about it, if you want to get into AI/machine learning, after a while, you are faced with a great branching point. You either go to the empirical side and start to build, say right now it's deep learning, but who knows what system it will be in the future. It will be very large, takes the whole server of a company, blah, blah, but that's that empirical side. Or you become a theoretician. You start to say, hey, what's the foundation of learning? And how is it related to mathematics? So this becomes this interesting divide. By the way, the divide is artificial, right? So in theory, there shouldn't be a divide. It just should be everybody is happy in both branches. But in reality, there is this branching point. And I'm now moving toward the theoretical side. And I do hope that I have had more preparation in this regard. So I guess to distill this a little bit, like just to step up one level, both Matt and I are saying we wish we have learned things that will make what we do even better.
All right. Just to sort of wrap up, do you have any just general advice for the students where they're at now, if they're, how to, how to contact you after today if they have any other questions? We can, if you're available to stay a little bit longer, we can continue with some of the other questions that were submitted, or if students want to stay on the call a little bit longer, you're welcome to. Yeah, just any general advice for students as they're like moving up. I think we probably have a lot of sophomores, juniors, and seniors on the call today, if that gives you an idea of kind of where they're at.
Yeah, I mean, I'm happy to stick around for a little bit longer if we want to go through more questions. Yeah, so there was one question just that Andy and I have been answering in the chat, but about, being a TA as an undergrad. I just want to point out, as I mentioned there to the others, a lot of CS courses also have what we call peer mentors, which are sort of like being an undergrad TA for courses. So if you're interested in teaching, again, at a bite-sized level, like Jerry said before, that's a good option to consider.
I'm typing something. I have, so sorry, just typing.
No worries.
Good. So advice, general advice, right? So one is you want to broaden your horizon beyond the classes. So one great way to do that is actually to go to seminars. This is just like, as an undergrad, we actually expect you to have no idea what the talk is about. Right? So it's not about really understanding it, but just to see the frontier of research in many different areas of CS. And actually that applies not just to CS, it really is for anything, right? So, and this is really easy to do now, given that everything is online. So that's a good opportunity. So definitely do that, because it gives you a good sample of what people care about. What are the problems people are asking, questions people are asking. So that sets the research landscape. Second, I just want to repeat this, right? So if you want to get into research, utilize professors' office hours and be persistent.
Persistent is key. I know. Professors get lots of emails, so you do sometimes have to keep searching for them. Kate is asking where we can find seminars.
I'll post the link to the events calendar. I'm just making sure I got the right link, if you give me one sec.
Awesome. Yeah, I'm assuming they're all virtual right now, but they do happen quite often. So so definitely keep an eye on that and attend when you can. And normally, isn't it when they're on campus, there's usually some cookies involved as well. So
usually, yeah.
When we're back on campus, hopefully we'll see you at some of those. So so yeah, I just want to thank you both again for being here. I think I'm going to stop the recording at this time. But if anyone can stay on or has any other questions, I am able to stay on until about 6 o'clock. So if anyone does want to stay on and ask a few questions, you're welcome to do that. I'm sorry we didn't get to every single one of the submitted questions, but the conversation was just so great. You just want to let it happen too sometimes. So, so thank you again. We're definitely happy to have you here. And I have a feeling you'll probably have some more emails and visits to your office hours after today. So, so thank you again. And I'll just stop this recording here.